In this problem 5, we've got a system of two linear equations and two variables that we are going to solve using the method of matrices. So let's first start by putting this system into the augmented matrix. Now I'm just going to read down the rows, the columns. 2, 3, then -8, -8, and then 6 and 13. Now I want a 1 in that top left position, right? My main diagonal here, I want a 1 here. So how do I get a 1 here? Well, I've got a 2, I can get a 1 if I just divide this entire row, or I'm dividing an equation, both sides by 2. So here's my notation. Row 1 is going to become the current row 1 divided by 2. And here's what that looks like. Just look at row 1 and divide every element, all three of those, by 2. We'll get a 1, a -4, and a 3. Row 2 stays the same. 3, -8, 13. Now I've got a 1 in that top left position, and I'm going to call that my pivot element. I'll circle it. And I'm looking to get a 0 in that position. So that's the second row. So I'm going to have to change the second row. So here's how I'm going to do this. The second row is going to become, now here's how it always works. It always works like this. I'm going to have something times the pivot row. And then I'm going to add the row I want to change. So what is this number right here, this multiplier? Well, it's always the opposite of the number you're trying to make a 0. In this case, it's a 3. So our multiplier here is going to be -3. So I want to multiply by -3. So let's do that. -3 times every number in the first row, right? What I'm really doing is just multiplying both sides of that first equation by 3. So it's a legitimate operation. So here's what this is going to look like. It is going to be 1 times -3 is -3. -3 times -4 is 12. -3 times 3 is -9. And I'm going to add that to row 2. So here's what we get then. Row 1 stays the same. 1, -4, and 3. And then let's add this row to this row. All right, component-wise. So first and first, 3 plus -3 is a 0. That's what we were looking for. Then -8 plus 12 is a 4. And then 13 plus -9, well, 13 minus 9, that's another 4. So we've got some progress here, right? We've got a 1 in our upper left position and a 0 below it. Now I'm going to go over and down, right, to the right and down, so I'm in that diagonal, and I want to get this to be a 1, all right, get that 4 to be a 1. And the way I'm going to do that is this. I'm going to divide, all right, so row 2 is going to become the current row 2 divided by 4, right? I can get a 1 here if I divide it by 4, so I'll divide everything in that second row by 4. So row 2 will become the current row 2 divided by 4. I'll do it up here at the top. So row 1 stays the same, 1, -4, and 3. Now dividing by 4, 0 divided by 4 is 0. And then both those divided by 4, what do we get? Well, those are 1s in both. Now I could actually stop here, and this is how the book is doing the examples. This is called back substitution. What do I have here in that second row? I've got no x's, 1y equals 1. So I know y is 1. I could put that 1 for y right here or up here and solve it for x. But I'm going to continue getting this into row-reduced echelon form, from which I can just read off the solution. So on my main diagonal, there is my pivot element, and what I want is this to be a 0. So I want to convert that -4 into a 0. So row 1 is going to become, all right, now it's going to be something times the pivot row, right, plus row 1. And what is that something? It's always this. Look at the number you want to convert to 0 and take its opposite. Opposite of -4 is 4. That's our multiplier. So let's see what this looks like now. So what I'm going to do is I'm going to run 4 through this entire second row, times 4 times 4 times 4. So it will be 0, 4, 4, and then I'm going to add that to row 1. So here's our new and final matrix, I think. We're going to have, all right, row 1, up here, row 1, and I'm going to add it to our circled row, component-wise. So up here, first and first. 1 plus 0 is 1. Negative 4 plus 4, that's 0. That's the 0 we were looking for. And then finally, in the third column, 3 plus 4 is 7. Second row stays the same, 0, 1, 1. Now I can read off my solution here. I got to remember the first column is the x, the second column is the y. So what does it say? What have we got here? 1x, no y, is 7. So from here, right, this is in our REF, so we can say x is equal to 7 and no x, but a y is equal to 1. So y is equal to 1. So we can write it like that. That just summarizes it. Or if you want to think of it geometrically as the intersection of those two lines up at the top, if we were to graph these two lines, they would intersect where? Well, to the right 7 and up 1.